So today, if you want to know where it is in the book, it's section 6.6.4. It's called compound inequalities. Now what this is, it's going to be very similar to what we did last class. We're just talking about more than one inequality at one time. Compound, where there's multiple of them. Okay? We're just going to be doing the same thing, but more than one time on a number line. Graph the solution set of x less than 3 and x greater than or equal to negative 2. So we call this a compound inequality because there's more than one. There's two of them. There's and. Okay? So we want to graph what works for both of these. Now, what numbers would actually work for both of these? What are examples of numbers that would be less than 3 but bigger than or equal to negative 2 that would work for both these? There's plenty. What are they? 2 would work. What else? 1 would work. 0 would work. Negative 1 would work. Negative 2 would work, right? It'd be greater than or equal to negative 2, less than 3. 3 would not work though, right? And you could keep going. You could start going 2.5, 1.01, and there'd be an infinite amount of decimals, fractions, that sort of thing you could put. So what we want to do is we want to put both of these on a number line to see what would work for both this and this now, instead of just one of them. Okay? So what we can do is we can graph them both separately and see where they intersect, see where they overlap. So if I was to graph this one first, just the x less than 3, say I put this on a number line, am I going to put an open circle or closed circle on 3? Open, because it's just 3's not part of my answer, because that makes it false. And then I want all the x's less than 3, so should I go to the left or right? Left, right? Because that would be 2, 1. All of these numbers make this true. If you plug in 1 here, 1's less than 3. If you plug in 0, and so on. And then if you graph this one on the right, and you had, negative 2, negative 1, 0, negative 3, and so on, it's going to be a filled in circle right on negative 2, and I want all the x's greater than or equal to negative 2, which means that would be towards negative 1, 0, and so on. So I want to put these on the same number line and graph where they intersect, where they overlap. So if I did that, it would look like this. If I put negative 3. If I look at this one, I went from open circle 3 that way, and here I went from closed circle negative 2 that way. That means every point in between here works for this compound inequality. It works for both of them, right? Negative 1 would work, 0 would work, 1, 2, 1/2 would be right here, 1.5 would be right here. So every number that falls in this shaded area makes both of these true. If it's not in this shaded area, it doesn't make both of them true. It's a compound inequality, more than one. Okay? So we are just putting the two different inequalities on the same number line and seeing where they overlap. Okay? This is a compound inequality. P less than or equal to 6 and P greater than 2. Graph the solution set for those two inequalities, for that compound inequality. I'll give you a second to try that. Now your number line might be more or less labeled than mine, but I just want to make sure I have 2 on my number line and 6 on the same number line, because I'm putting them both on there. Right? So I started a little bit below 2 and finished a little bit above 6. Okay? So if I just look at them separately, again, I want P less than or equal to 6. So that means on 6, that means 6 makes it true, right? Because I could plug in 6 for P and this would be true. So that means I need to cover it up. It's part of my solution. And all the P's less than or equal to 6 are that way. 5, 4, 3, 2, 1, and so on. And then if I wanted P greater than 2, here's 2. Is that part of my solution? No, because that would make it false. So when it's not part of your solution, you put an open circle, and all the P's greater than 2 go that way, which looks like that means this is my intersection where they would overlap. So anything shaded on this number line here works for both of these. Anything not shaded doesn't work for both of them, right? For example, 7 would work for this one. It's greater than 2, but it doesn't work for this one. So that's why it's compound. It's got to work for both. Okay. On the right, one of them has the variable. Oh, sorry, they should be the same variable. Let's say they're both x. One has the variable on the right side of the inequality, one has the variable on the left. If you don't like having the variable on the right side of the inequality, just move it, but just make sure you flip the sign. This is the same thing as this, right? If I move the x, oh sorry, not that, I need to flip the sign, as that. 0 greater than x is the same thing as x less than 0. So if you like it where the variable's on the left, just move it, but make sure the sign flips the other way too. It's pointing towards the x here, it should point towards the x there. So these are the same thing, and then you would continue the same way. All right, so we saw how you can have two inequalities and graph them on the same thing. Now it's possible that you can write them all in one line, but just with two equality symbols. So what that could look like is if you had something like this. Okay, so this is still a compound inequality. There's still two of them there, but it's all written together. And if we want to graph the solution instead of this, we can break this up into two different inequalities. One of them we can just kind of ignore this one, and one of them we can just kind of ignore this one and graph them together. It's the same thing as we did before, except that it's just all written in one line. So if you wanted to break it up, it would look like this. You'd have 5 greater than x is the first one, and x greater than -1 is the second one. This blue thing is the same thing as this. I just have it written together in the top one. So, we put that on a number line. We'd have, let's say we wanted to cover -2, -1, 0, 1, 2, 3, 4, 5, 6. So we graph this one. Again, if you don't like the variable on the right, you can always switch it. Just make sure the sign flips, which I didn't do. 5 greater than x is the same thing as x less than 5. So you go to 5, open circle. You want all the 5 to be greater than x, so that means you need to go towards the less than side. And in this one, x greater than -1, you'd go to -1. You want all the x's greater than that, so you'd go that way. So the solution set would look like that. Everything in that shaded area would be a solution to both of these. Okay, anything in this shaded area you could plug in for x, and this would be true, both of those inequalities. But it's possible you see them written together like that. Okay, so if it's written together and you want to break it up, you can just break it up into two separate ones and do the same thing. And then the other thing you could see is instead of just being a variable in the middle, you could see an actual expression where you'd have to solve it just like we did last class. So what that could look like is if you had -5 less than x minus 4 less than 2. So say you had something like this, where you have two inequalities here, but on the inside it's not been solved yet. So we're going to have to solve this one twice and then graph it. So again, if we just break it up into two separate ones, -5 less than x minus 4 is the left one, and x minus 4 less than 2 is the second one. See how I just broke that up into the left one and the right one? And then we just solve both of these separately. So on that red one, on the left one, what are you going to do to solve for x there? In this one. Just add 4, right? To get it variable by itself, we'll add 4 to both sides. Leaves us with -1 is less than x. And on this one, we'll do the same thing. We'll add 4 to both sides, and we get x is less than 6. So now we can graph this compound inequality on a number line. So I want to make sure it has -1 on it, and I want to make sure it has 6 on it. So if -1 is less than x, and again, if you flipped it around, it would look like that. So that means I want all the x's greater than 1. So that would go that way. I want all the x's less than 6, so that would go that way. That means the answer to this inequality is everything in between there. Okay, excuse me. We'll have to flip this one. The only reason I did, because a lot of people like the variable on the left so they can read it that way. So if you would rather have the variable on the left, you could put it on the left side, just flip the sign. But you don't have to if you don't want to. That makes sense. If you can graph it just by looking at that, go for that. You don't have to flip it. Yeah, that's just one extra step. Okay. Compound inequality all written together. We want to graph the solution. So what can you plug in for x that would make both of these true? Again, we'll break them up, solve them, and then graph them. So I'll let you try that first. So we broke them up separately. We did the left one, we did the right one. We'll solve each of those, and again, it's just like if there's an equal sign, except if you ever had to multiply or divide by negative, the sign flipped. So in this one, we'd subtract 7 from both sides, we'd get -1 is less than or equal to x. Again, if you read it the other way, x is greater than or equal to -1 is the same thing. Same thing, you subtract 7 both here, and you get x is less than 3. So these are the two things we want to graph on our number line. Okay. So I'm going to put -1 on the number line, and I'm going to make sure I put 3 on the number line. So if I do this one first, I want all the x's less than 3, open or close circle on 3. Open, right, because 3 is not included. 3 is not part of the answer because it would make that false. And then I want all the x's less than 3, which means that's 2, 1, 0, and so on, all the ones that way. This one, closed circle on -1 because that's included. That would make that true. And then I want -1 to be less than or equal to x, which again, if you flipped it around, would look like that, or x greater than or equal to -1, which means they go that way. So all the solutions are in there. That means 1, 0, 1, 2, but not 3 would all make this true if you plugged it in. You know, if you plugged in, let's say 1 is covered up, right? So if I plugged in 1 here, it would say this. 6 is less than or equal to 8, which is true, which is less than 10, which is true, because 1's part of my answers. But if I plugged in 4 here, it's not going to make both of them true. It might make one of them true, and it would make the first part true, 6 less than or equal to 11 if you plugged in 4, but it would not make the second part true. Okay, so this is our solution area, our solution region. Compound inequalities, there is one other case, but this case is actually much easier if you had something like this. Let's say we use variable a. And instead of using the word and, use the word or. So and means they both have to be true, right? Or just means one or the other has to be true. So if ever you see the word or, it's really easy because all you have to do is graph them both separately and it doesn't matter what happens. Because it's either this one has to be true or this one. So you're just basically putting both answers on the same number line. If it says and, you only want to cover the region that makes both of them true. So like in this one, if we solve this first one, we'll subtract 1 from both sides and get a is less than 3, so that one's done. And on this one, we'd add 1 to both sides, so we'd get a is greater than or equal to 4. So since it's either this one is true or this one is true, we're just going to put them both on a number line. So you know, if I go 1, 2, 3. So this one, a less than 3, I'm going to go to 3, and I want all the numbers less than this. Or a is greater than or equal to 4. That means closed circle there, and all the numbers that way. So that's how I'd graph that one, because either this one or this one. You just put them both. Now, if it was the word and, those never cross, so there would be no region that crosses. But if it's the word or, you just put them both on the number line separately.